Hello and welcome. My name is James and I'm from the DSO Imager channel. And in this video I'm going to go over a recent picture I took of M106. Now I do have the finished image posted on my Astrobin page, and you can find my Astrobin if you go to my main YouTube channel page. On the right there's a little icon / link that'll take you right to my Astrobin page. So anyway, I'll bring it up here really quick just to give a view of the integration here. So I have a total of basically 42 hours, and you can see that most of that is in Luminance. Now the thing is, here it is with the edge in this 294 mono. The 294 mono does have a characteristic where it does not perform well if it's starred for signal. So if your exposure is too short, for example, or your gain is too low, you'll get banding and some pretty bad noise characteristics. Now typically 120-second subs has been pretty good for broadband pictures, but what I've discovered, and unfortunately 12 hours in, is that on a galaxy shot 120-second exposure is not really giving me enough signal, and so the noise in this overall image is worse than I would have preferred. So I got about 12 hours in and I'm looking at the subs and I'm thinking more data, that'll smooth out the noise, and then I realized, wait a minute, I'm not exposing long enough. And so I went back and started shooting 3-minute subs, and I got 8 hours of that, and I just decided to add it up, and so that gave me 20 hours of luminance. And so, I mean, the picture is a bit grainier than I would have hoped, but it came out alright. You can see here I got almost 10 hours worth of color and 11 hours of HA. Now, of course, M106 is famous for these very bright, significant HA regions, filaments that are coming out, and I wanted to capture that. Plus, you know, during galaxy season when you have a full moon up, what else are you going to shoot? So a lot of this HL alpha was picked up with a bright moon out there. And as far as how I put the luminance together, I just had separate stacks, the 122nd and the 182nd, and then I just used Deep Sky Stacker to stack those two stacks on top of each other. Alright, so let's take a look at the initial stacks. Here's the 20 hours of luminance on there. And there's our blue. Note the gradient. Green. Red. There's our HA. Right, and there's the HA bits we're after. And of course, dynamic background extraction does a pretty nice job. So here's our luminance. This is just auto stretched. In fact, let's take a look at the core here. What I'm doing is I'm using the mouse wheel right here on this K value, just kind of scrolling down. I'm zooming in. I can grab this middle one and pull it back. Yeah, so we got some dusty bits in there. And so for the RGB, what I do is I do a linear fit. Right, and this is pretty handy. So you do a linear fit, you put your blue in here. And then you apply the blue linear fit to your other channels. And then when you put them together in the RGB combination tool, it's done a lot of the work with the color calibration. And then notice just by doing that, we've got some blue in here. I mean, there's more work to be done, but the color in galaxies is really difficult to pull out sometimes, and so it helps to have it in a good state to begin with. So after that, I ran deconvolution against the luminance. Here it is. Let's pull that back a little bit so we can see the detail. I mean, notice, we've got 20 hours here of luminance, and you can't really see any of the HA region, right? But anyway, so deconvolution against the luminance, and I ran deconvolution against the HA. That area is looking pretty good. You've got some bits on that part there. And so after running deconvolution against the luminance and the HA, we've got to put the two together. So it's actually it's a three-step process, and I've covered this in other videos on my channel. In particular, I have one that talks about boosting your LRGB images with HA, and it's a method that uses pixel math. So the first process, or first pixel math formula, is right here, and this may look a little crazy, but that's just because of the name of the file, right? So there's that HA. So it's just the HA minus Q. Q is going to be our variable, times the red minus, I think this is median, and then times red again. So I did have to prep the red channel, even though I just go straight. Usually what I do with LRGB stuff is I put the RGB together in the LRGB combination tool, and then I run dynamic background extraction against the completed RGB image. Because I have found that if I run dynamic background extraction on the individual red, green, and blue, I still sometimes get some weird color gradients in there. So it just seems to work better to combine the color channels together, run background dynamic extraction, and work with that. But with this particular formula, because what it's basically doing here is it's separating out the HA data against the red data, you need the red to be prepared. And so here's the red channel with dynamic background extraction run against it. And so the result of this, here's the variable. The result of this is these HA clean files that I have here. And so you can kind of get an idea of what's going on. If we compare this to the HA, you can see how it's removing a lot of this extra, honestly, non-HA signal, right? It's getting this non-HA stuff from the red, and it's isolating just the HA, because that's what we want. And so I've run this a few times, playing with that variable, and so this is an example of going too far with it. And I believe this one over here is the one that I used. Might have been this one too. So one of the things, if you run through this formula and you don't go far enough, you end up with all this background stuff, the whole combined RGB image has this pinkish hue to it. Alright, so the next step is to actually use this data against the RGB to create what's called the enhanced RGB. And here's the pixel math formula that I use. So now, if don't worry about trying to copy it off my screen here. I'll include a link to the article that I used in the video description, and also in that other video I include the link, and I go into pretty more detail about how to go through this process. But anyway, this is the formula here, right? So T, that's target, right? Because you're going to apply this to the RGB image. So you drag and drop this on there. So T for target, right? B is our variable boost times HA clean 2, so that confirms that this is the version of the HA clean that I use. HA clean minus median times HA clean 2. For the green channel, simply target. For blue channel, target plus boost. It's basically, I think it's the same thing as the red. And then symbols, there's our boost. And this is the value that you can play with. And you can see here, see, this is an example of the boost value being too high because the whole galaxy's pink and we got pink in the background noise. Basically, that's too much HA signal spread out. And so it's just, I try different variables. It looks like I went in the wrong direction with this one because it looks even pinker. And it was probably 3 or 4 that I ended up with. Yeah, I mean, this doesn't look too bad. So we got just enough HA over here. Actually, I think I went with this one. Yeah. So we get a little bit of the HA there. I mean, it's not bad, and it's not overpowering the whole image. I suppose I could have went with something stronger like this and then play with masks and fight the background, but anyway. And then for the third step, we actually have to add the HA to the luminance, because if we have this and we did all this work to get our HA signal in there, and then we apply the luminance, it doesn't have any of it in there, we're gonna lose most of this exquisite detail from the HA. So it's the same formula basically. There it is, target B. And what I ended up with, you can see I really played a lot. Oops. I really played a lot with that variable. Alright, you can see a hint of it there. Now, you see this grain in the back? It's like worse. So, it's an example of where it's too strong, and I think the noise from the HA, because that issue I mentioned earlier about if the signal is too weak, you get this banding. You can see these little bandings on this screen. So even at 10-minute subs, it gained 200 on HA. It's still, I think I was just on the threshold of signal. And with this camera, this 294 mono, when you go beyond 10 minutes, you start to run into problems with dart calibration too. So maybe in the future what I need to do is, for the HA parts, is increase the gain beyond 200. I mean, dynamic range is probably not too important when we're just trying to get the HA regions in galaxies. But anyway, here's some other examples. So the data is what I had to work with, and I had to find a balance between this noise while still getting the HA in there. And so I think like this fifth attempt was probably too light. Alright, the thing with auto stretch, of course, is that you have to, the galaxies are really bright, so it is a benefit to pull this back and get an idea of what you're looking at. Now, when I work on these images, I try to keep things organized well. You can see how I've got everything out here. And I do it this way knowing that I'm going to do a video. But then somewhere along the way, I kind of fall out of this. So the rest of it's pretty ugly. And I think this video is mostly going to highlight blending in the HA with the color data, because it's going to be difficult for me to follow here. So I went to this other workspace. I had the enhanced luminance and the enhanced RGB, and I tried different variations of putting these together. And so if I just, like here, this one's a good example. Right, so this is the RGB, enhanced RGB, right, there it is. And I blur it out using this right here, multi-scale medium transform, and I just disable the 4 layers and apply that, right? So if I have this and I drag and drop this on here, the result's going to be this. Right? We do this to eliminate color noise mostly. Then we apply the luminance. And if your luminance signal is too strong, notice it kind of kills the color a little bit. And so I was trying different strength values on the pre-stretched luminance. You can see it over here. Alright, this is me stepping, oh, not that one. This is me stepping through manually stretching. Like typically I do auto stretch, no, excuse me, on broadband I typically use the easy processing suite, soft stretch. But I found that using the soft stretch, the galaxy was still too strong, and it was completely killing all the colors. So after I got it all together, I did work with masks, right? So you can see a mask right there. And this is actually pretty close to the final image. I did remove the stars so I can give some attention to the HA regions. And as you can see, a ton of masks. I mean, we've got some game masks. Oh, what this one was for is this little guy in the corner. You'll see it in the completed image. There's like a little galaxy in here. I think it's a galaxy, and it's blue. Other pictures I've seen, it's blue. And in my processing, I kind of nuked the color a little bit. So I just made a mask to put some color in there, and all I did is I just increased saturation, and the blue came back, which was nice. But anyway, yeah, I mean, look, lots of range masks, game masks. I mean, here's a mask that I was trying to give the HA. I mean, the whole reason to shoot this galaxy is for the HA stuff, at least for me this time. It's the second time I've shot this galaxy. I shot it before with my 70mm scope, and I really wanted to get this. And so I spent a lot of time working on different masks so that I can do some, yeah, I mean, what do you think I'm working on there, right? That little HA column there. So I spent a lot of time trying to enhance this area here. And so anyway, after a lot of fiddling around, this is what I ended up with. So there it is, 40 hours with an Edge HD8 and a ZWO ASI 294 mono using astronomic filters. The HA was a 6 nanometer. The RGB were the astronomic deep sky filters, and for luminance I was using the astronomic L3. And this is what I ended up with. There's that little guy down there in the corner. Yep. Alright, so anyway, I'd love to hear what you guys think on this one. Kind of surprising, M106 doesn't have a name, not that I know of. Thank you for watching, and clear skies.